Hello everyone. Today we're going to be talking briefly about the unit circle. This is not going to be an extremely intense conversation. I just want you to be familiar with it, especially when you go to pre-calc or pre-calc honors next year. So let's first look at what's going on here. The word unit usually means for one. Kind of like if I wanted to find the unit price of something, it's how much something costs for one pound, for one thing. So the way that the unit is referred to in this is that if you think of this as kind of an X and Y axis, all of these lines that make this circle have a length of 1. So everything has a length of 1. This length of that line is 1, that's 1, that's 1. All of them have a length of 1. Now, if we look at the degrees, there's very specific degrees that are on here. And it's really only the nice pretty ones. So there's only specific ones on here because these are the ones that are going to give us some nice answers. So 0, 30, 45, 60, and 90. We'll talk about the other ones in just a second because they're actually just repeats of 30, 45, 60, and 90. So I want you to look at just the 30-degree one. So the way that this coordinate right here came about is somehow on this coordinate plane, if we are talking about this being on a coordinate plane, we started at the origin, we went over 3 pi over 2, square root of 3 over 2 places, and then we went up 1/2. So we went over the square root of 3 over 2, and we went up 1/2. Now the 30 degrees is that right there. And what we also know, if we create this lovely triangle here, is that this length is a length of 1 because it is a unit circle. So we've actually just created a right triangle. We may have created a right triangle with 30 degrees. Now I want you to think about something. If I were to find the sine of 30 degrees, it would be the opposite, which is 1/2, divided by 1. And what's anything divided by 1? It's just itself. If I were to find the cosine of 30 degrees with this triangle, it would be the adjacent, which is the root 3 over 2 divided by 1, which is just root 3 over 2. Which coincidentally, this coordinate, this is actually the cosine, and this is the sine if we were to do 30 degrees. So one of the things about a unit circle is that the coordinates are actually giving you a sine and a cosine answer. So while those coordinates are saying how to get to the end of that 1 unit line, it's also giving you sine and cosine answers. So all of these coordinates here are sines and cosines. So if I wanted to find the cosine of 45 degrees, it is square root of 2 over 2. If I wanted to know the sine of 60 degrees, it is the square root of 3 over 2. So the unit circle is actually giving you specific sines and cosines. Now what it's not giving you is tangent. However, I want you to think about something. So if sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse, and tangent equals opposite over adjacent, there's actually a way you can use sine and cosine to create tangent. And the way this works is I always think of it as sine uses the opposite and cosine uses adjacent. So let's actually substitute. So I just said sine is opposite over hypotenuse, and that's over the adjacent, or cosine, which is adjacent over hypotenuse. If I'm going to divide two fractions, I'm going to multiply by the reciprocal. So the opposite over the hypotenuse multiplied by the hypotenuse over the adjacent. The hypotenuses cancel out, and we have opposite over adjacent. So tangent is the same as sine over cosine. So if I were to look at this triangle, let's just say I wanted to find the tangent of 30 degrees. I'm going to take the sine answer, which is 1/2, and I'm going to divide it by the cosine answer, which is the square root of 3 over 2, which if you remember back to 6th grade fractions, that means I'm going to multiply by the reciprocal, and my 2's cancel, and I have 1 over root 3. So the tangent of 30 is 1 over root 3. So you can use your sine and cosine answers to find the tangent. So it actually is giving you all 3 of those trigonometric functions. However, it's also giving you the other 3, the cosecant, the secant, and the cotangent, because the sine is the reciprocal of the cosecant. So if I did 1 over sine, I would get the cosecant. So if the sine of 30 equals 1/2, then the cosecant of 30 equals, flip it over, 2 over 1. If the cosine of 30 equals root 3 over 2, then the secant of 30 equals 2 over root 3. All you got to do is flip it over, okay? Now, I've only been looking at the first quadrant essentially. The rest of it is the same stuff but with positives and negatives. So let's first talk about, there is a pattern in the actual coordinates here. So first of all, the square root of 1 is the same as 1. So technically, you could put a square root there. So if you look at the cosines, they are going from 3 to 2 to 1. They are going decreasing, square root of 3, square root of 2, square root of 1. Where the sine is going the square root of 1, the square root of 2, the square root of 3. So the cosine's getting smaller as it goes up, and the sine is getting larger underneath the radical sign as it goes up, and everything is over 2. Every single thing. Now, if you were to find a matching pair, let's just talk about 30 degrees. This 30 degrees looks very similar to this 150 degrees. The only difference is a negative sign. So if you think about the first quadrant, these are all positive, comma, positive answers. The second quadrant are all negative, comma, positive answers. So this 30 degrees and this 150 degrees are essentially the same, but in a different quadrant. So how do we get there? Well, if you took 180 and you subtracted 30 degrees, you'd get 150 degrees. So it is the same angle, but it's reflected, think geometry, reflected over the y-axis. Then the 45 degrees, again, same idea as the 45 degrees. If you were to take 180 and subtract 45 degrees to go backwards, you'd get 135 degrees. And you'll notice instead of root 2 over root 2, it's negative root 2 over root 2. And same thing with the 120 degrees. It's related to the 60, and it's just negative 1/2 over, comma, root 3 over root 2. So if we think about the rest of them, quadrant 3 is negative, comma, negative. And if you'll notice, every single coordinate is 2 negatives. And the fourth quadrant is positive, comma, negative. So all of them are essentially 3 answers with positives and negatives. That is one thing that I want you to try to memorize. So there's going to be a blank unit circle, looks like this, and this is what I want you to try to fill out as you go. So you're going to fill in your degrees, so like you'd fill in 30 degrees here, you'd figure out your coordinates, and so on. So if you filled in 30 degrees here, you know 30 degrees less than 180 is 150 degrees, and that's going to match over here. Couple more things. Little reminder of radians. So this is a mess. Hold on. So if we were talking about radians, remember that all the way around, you can probably hear my grandfather's clock in the background right now. All the way around gets you 2 pi, which means that halfway around gets you pi, which is why that's pi. So if we do the fractions, half of pi would be pi over 2. 45 degrees is like half of that, so that's pi over 4. This one is pi over 6 and pi over 3. So we've actually dealt with the radians before. I want you to see if you can remember those ones. 2/3, 3/4, 5/6 pi, and so on. Okay? So we have coordinates, we have degrees, we have radians. Little reminder, if you want to take degrees, if you multiply it by pi over 180, you get radians. Okay, so another little reminder, all those things that we did before spring break, they're in your notebook, they're in your brain somewhere, okay? The zeros, we have 1, 0, 0, 1, -1, 0, and 0, -1. Don't forget those, okay? Then the what's positive and what's negative. So in terms of the first quadrant, they are all positive because the coordinates are positive, positive. In the second quadrant, since they are negative, positive, remember sine is the second one. Cosine is essentially the x-coordinate, that's negative. Since tangent uses cosine, it's going to be negative, and all of their reciprocals go with them. Since the bottom left-hand corner is negative, negative, the sine and cosine are both negative. Now the reason the tangent and cotangent is positive is because a negative divided by a negative is a positive. And in the bottom right-hand corner, which is positive, negative, the sine, which is also the tangent, because sine is used in tangent, are going to be the negatives, and the cosines are going to be the positives. So I know that's a really short reminder as to what exactly the unit circle is. The PDF of this is in your assignment. I want you to try to recreate it a few times, look for those patterns, see if you can memorize it. If we were in class, you would be memorizing this and you would be taking as many tests as you had to 100% answer this on the first try. So I'm not doing a turn-in assignment for this. It is completely up to you. Your quiz on Friday will ask you some questions. Since you'll have it in front of you, it's mostly can you read it. I want you to see if you can print this, print this. If not, recreate this on a piece of paper. Start memorizing it to the best of your ability. If you have any questions, let me know. If you're doing your AP tests right now, I hope you are taking the time. You are like not freaking out too much, that you're doing well. If you're doing this assignment late because of your AP tests, don't worry about it, okay? Have a great day. Let me know if you have any questions.